Hi everyone, thanks for watching the video. Last week we were working with adding positive and negative numbers. This week we're going to start looking at subtraction and kind of seeing if we identify any patterns or things that could help us in the future. So Arduino says, what is the algorithm we determined last class for the addition of integers? And something that we said is that when the signs are the same, add and keep the signs. When the signs are different, we subtract the absolute values and keep sign of the greater absolute value. And if I'm really being specific, we add, I'll say, the absolute values and keep the sign. So these are the two algorithms we were looking at yesterday for two different situations when we're adding problems with the same sign. We add the absolute values and keep the sign of whatever that was the same. So two negatives, we would add the negatives together, their absolute values, and we'd keep the sign. And then if the signs are different, one's positive, one's negative, subtract the absolute values and keep the sign of the one with the greater absolute value. So number two, without finding the sum, determine whether the following will be positive, negative, or zero. We have a whole lot going on in this expression. We have some positives and we have some negatives. Well, if we started combining things, 12 and 20 together would make 32 positives and negative 16, so 16 red chips and 17 red chips together would make 32 red chips. So the question is are we going to get a positive, negative, or zero? Well, we can't get typo. I'm sorry, that's 33. We can't get zero because the values are not the same. They're 16 and 17 together makes 33. So 33 negatives and 32 positives are not the same. So it can't be zero. Can we have positive sum? Well, if that was the case, we'd have to have more positives than negatives. We only have 32 positives. There are 33 negatives. Can't be positive. Therefore, it must be negative because there are more negatives than positives. How many more? One more negative. So if we were to actually simplify this further, we could find out that the value of the expression is negative 1. But you didn't have to do that. Quizzes were given last week and some people were using extended time. I can't give everybody infinite extended time because that would cause some problems, so you need to have it made up as soon as possible so we can get quizzes back and people can see what they got and the mistakes that they made so they can learn from those mistakes. Also, another announcement, starting on Tuesday, this Tuesday, tomorrow, I'll be in room 228 after school for extra help, and I will be there every Tuesday afternoon after school. Now, you're also welcome to come during lunch, 7th period. You can bring your food, you can eat while working, you can work for a little bit, stay for a little bit, go back down to the lunchroom. I don't care. So every day during 7th period and Tuesdays after school in room 228, you can meet for extra help. So think of a number. Get that number in your head. I want you to add 0 to that number. So that number plus 0. And what'd you get? Did you get the number that you started with? I'm sure you did. Okay, different situation. When you think of a number and its opposite, so visualize a number line. Pick a number and its opposite. Now I want you to add those two numbers together. What did you get? You should have gotten 0, right? 5 and negative 5. Add them together, 0. 10 and negative 10, add them together, 0. 1 and negative 1, add them together, 0. So These two situations show us these identity properties. Additive identity, when you add 0 to a number, its value doesn't change. Additive inverse, two numbers, let's use A to represent one number, B to represent the other number, that satisfy the equation A plus B equals 0. And that only happens when you have two opposites. Okay, so a situation. 3 and negative 3, they're additive inverses. When you add them together, you get 0. Positive 1/2, negative 1/2, put them together, you get 0. There you go. Kim has 9 DVDs. She sold 4 at a yard sale. She now has 9 minus 4, 5 of those DVDs left. One way to represent this situation is to use a chipboard. So today we discussed, yes, I could take 5 of those integer chips and move them off of the board, and now my board, 4 of those integer chips, move them off the board, and now my board has 5. That's one way to do it. Other than taking 4 positives off, what is another way we could make the value of the board 5? So I'm going to go back. We have the 9 here. How can I also get my board to show a positive 5 by not just removing these 4? Well, one way, instead of taking the 4 black chips off, we could take 4 red chips and put them onto the board. The 4 red chips and the 4 black chips would make 0 pairs and cancel each other out, therefore leaving us with 5 positives. So the big idea for today is that taking positives away or adding the same number of negatives are basically the same thing. If I took 4 positives away, or I left them and I added 4 negatives in, both results get me the same thing, positive 5 in this particular example. So we're going to be focusing on that today. Let's skip that. Alex had $8 in his bank account. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. He used his debit card to pay for $12 lunch. How can we find how much money is in his account? Well, we have some options here. We could take 12 blacks away, right? But wait a second, we only have 8. So what can we do? We can use 0 pairs. I can use a 0 pair here, and we can bring out another one, and another one, and another one, and now we have 12 that we can take away, right? So we could take away these 12, and what are we left with? Right here, negative 4. We'd have negative 4 left over. Is that the only way? No, that's definitely not the only way. We could, here's his $8, right? Let's try to do this a little bit more expeditiously. All right. So here's his $8, and instead of adding in the 0 pairs like we did and then taking things away, we could just take the 12 that he's spending and use it as negatives to represent that he's spending 12, right? So there's 4 that he's spending. Shoot. Try again. 4 that he's spending, 8 that he's spending, 12 that he's spending. And if we do it this way, well, now we're doing it with 0 pairs, so cross these ones out. And same thing, we get the same result of negative 4. So whether we're subtracting a positive or adding a negative, it's the same thing. We get the same result. Same result. And that's the big idea, again, for today. So, 12 12 minus 8. You guys know this. You've been doing it forever. 4. Okay. Negative 5 minus negative 7. So I could take 5 negatives. 1, 2, 3, 4, 5. And if I want to take 7 of those away, I can't. So I'd have to add in some 0 pairs. And now I could take away the 7. Right? I could take away the 7 reds. And what are we left with? We're left with a positive 2 right here. Okay. I have 4 negatives and I want to take away 2 of them. 1, 2, 3, 4. I want to take away 2. So I'm going to take away 2. And what's left? Negative 2. I have 2 positives and I want to take away 4 positives. 1, 2. Well, I don't have 4 positives to take away, so I need to put in some 0 pairs. 1, 2. 1, 2. And now I can take away those 4 positives, right? What's left? Negative 2. Okay. I have 12 positives and I want to take away 8 negatives. 1, 2, 3, 4, 5, 6, 7, 8. Do we have 8 negatives to take away? No. We only have 0 negatives, so we need to add in some 0 pairs. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now we can cross off the 8 negatives, and we're left with positive 20. Here we go again. I have 5 negatives, and I want to take away 7 positives. Can't do that, so we need to do 0 pairs again. So 5 negatives, 1, 2, 3, 4, 5. And I want to take away 7 positives. So I need to have some positives on the board in order to do that. 1, 2, 3, 4, 5, 6, 7. And since I'm doing that, I need to add in 0 pairs. So my value doesn't change. Okay, now we have the problem shown right there. Take away my 7 positives. What's left? All these negatives. Negative 12. Okay. We have 4 negatives. 1, 2, 3, 4. I want to take away 2 positives. I can't do that right now, so I have to add in 0 pairs. 1, 2. 1, 2. Take away my positives now. How much is left? Negative 6. Whoa, I'm getting crazy with the colors. Negative 6. All right. We have 2 positives and we want to take away 4 negatives. Can't do that. So 1, 2, 3, 4. And my positives, 1, 2, 3, 4. Take those negatives away. What are we left with? 6. Positive 6. Okay. For the remainder of class, people worked in groups and desk partners working on these problems on those pages, so feel free to visit that. But again, the main idea here, the main idea is okay, sorry about that. So subtracting a positive is the same as adding a negative. This is the big idea for today. Thanks for watching. See you soon.